Right, okay. Students, can you all hear me? Can you hear me? Right, okay. Okay, students, I told you that I will discuss the 50 molecules that I gave you as an exercise under the Lewis structure practice exercise sheet. Okay, so there are 50 molecules that we have to practice here, and you will realize these things are not that much difficult, very easy. So let's follow the rules that we learn, and let's quickly finish this 50 molecules, right? Okay, before we go for the drawing Lewis structures for these 50 molecules or ions, you have to know that some important facts that we learn as a summary when we are drawing the Lewis structures, right? So in the theories, we learn that how to draw the Lewis structures and what are the 5 steps to follow. And both the online and physical batch, I think everyone finish how to draw the Lewis structures by following the 5 simple molecules within 5 steps. So as a summary, these are the things that you have to remember, okay? Students, remember when we are drawing the Lewis structures, always we have to give the priority for the octet rule. 8 electrons. 8 electrons is very important. At the beginning of the lesson, I told you that octet rule is actually followed by the second period elements mostly. For example, carbon, nitrogen, oxygen, fluorine like elements, they are making covalent bonds. So then they are satisfying the octet rule. But remember, again, I told you that third period elements like sulfur, phosphorus, chlorine, those like elements can exceed the octet also because of the existence of the third principal energy level. Because if they want, they can shift the electrons for the d sub energy level, and then they can keep more than 8 electrons in the valence shell. So therefore, always, but remember, for carbon, nitrogen, oxygen, fluorine, second period elements, we have to follow the octet rule. Octet rule is a must. And look at the second point. Second point is very important. Second point is related to the charge. I told you that when we are calculating the charge, we have to consider the valence electrons. Students, as a concept, we learn that what does mean by the valency and what does mean by the valence electrons under the theories. And you know that if you are given a particular element, how many valence electrons should be there? For example, when you consider fluorine, we know that in the valence shell of fluorine, how many electrons are there? 7 electrons are there. If oxygen is given, we know that valence shell is containing 6 electrons. Sulfur is containing 6 electrons. Carbon is containing 4 electrons. Likewise, we know that how many electrons are exactly existing in the valence shell in that particular atom. So therefore, you have to check the valence electrons. Now, when you consider oxygen, now in the valence shell of oxygen, there are 6 electrons. According to the electron configuration, can you remember? Oxygen is 1s2, 2s2, 2p2, 2p4. So therefore, this is the electron configuration of oxygen. So in the valence shell of oxygen, you can see that there are 6 electrons, 2s2, 2p4. So if there are electrons more than the 6, in case if there are 7 electrons, we know that the number of electrons count is greater. So that is a greater value. That means electrons are gained. Since the electrons are gained, we have to put the negative charge. In case, remember, in the valence shell of oxygen is containing 5 electrons. Normally there should be 6 electrons. But here now we have only 5 electrons. That means we have a lesser number of electrons. So therefore, we have to put the positive charge. Because lesser number of electrons are representing that electrons are removed from that particular atom. So therefore, by checking the valence electrons, we have to assign the negative charges or positive charges. If the valence electrons are okay, 6 means 6, that means neutral atom. Okay, you have to keep that in your mind. And finally, I have given you, this is also very important, the charge separation should always be minimized. Remember, students, I told you that when we are drawing the Lewis structures, even in the examples, we have to reduce the charge separation as much as possible, right? If they have given one negative charge inside that molecule, always try to put one negative. because we can many possibilities that can make minus charges, minus one charge, minus two, plus one also minus one. So therefore, try to reduce the charge separation. If it is a neutral molecule, try not to put charges, right? So that is very important. We have to minimize the charge separation inside the molecule or ion that we are dropping. So that is also very important, right? Look at this on third point. Hydrogen atom is always making a single bond. Students, under the Lewis structures that we drew, right? Did you see that hydrogen is making double bond? No, hydrogen never makes a double bond because hydrogen belongs to the first principal energy level. So it can keep only one electron. It has only one electron, can keep two electrons because in the first principal energy level, the maximum number of electrons that can exist is two. So therefore, hydrogen is making only one. Always, always. Huh? Then the next one, oxygen. Actually, you can see that most of the Lewis structures are containing oxygen, right? When oxygen is connected to another atom by a single bond, then we can consider that is a negative charge, right? For example, look at this one, OH minus anion, hydroxide. Look at this one. Oxygen is connected to hydrogen, right, through a single bond. So therefore, this is negatively charged. Why? In the valence shell of oxygen, we know that there are 6 electrons, but here we have 1, 2, 3, 4, 5, 6, 7. That means one electron is in excess. If one electron is in excess, we can tell that a negative charge belongs to oxygen atom. Try to understand. Okay. Then the next example, we can consider that a double bond. If oxygen is connected to another atom through a double bond, no charge. For example, let's consider the oxygen diatomic molecule. Then here we can see double bond. We know that when you count the valence shell electrons of oxygen, 1, 2, 3, 4, 5, 6, there are 6 electrons exactly belong to oxygen. That means what about the charge? There is no charge. In case if you have triple bond like carbon monoxide, can you remember we drew the Lewis structure for this one? Carbon monoxide, carbon is negatively charged, oxygen is positively charged. How that oxygen is becoming positive? 1, 2, 3, 4, 5. In the valence shell, there are 5 electrons. That means one electron is in less. Therefore, we have to put the positive charge. If oxygen is connected through a single bond, negative charge. If oxygen is connected through a double bond, neutral. If oxygen is connected through a triple bond, always oxygen will having a positive charge. And one more thing you have to remember, when oxygen is having a positive charge, we consider that is unstable. The reason is the second highest electronegative atom in the periodic table is who? Oxygen. So therefore, you have to keep that in your mind. Last point, actually, I explained you that one earlier. Third period elements like sulfur, phosphorus, chlorine, they can exceed the octet. That means they can keep more than 8 electrons. So therefore, students try to understand some of the molecules which are containing sulfur, phosphorus, chlorine. You will see that they are exceeding the octet. Already we have discussed some examples. Let's consider in this exercise also, we have few examples. Okay. So as a summary, you have to remember these things in your mind before we go for the drawing Lewis structures. Understood? So you have to remember these things. If you want to add anything here, you can add that one. No need to write down these things. Let's quickly go for the exercise. Right. So example number 1, xenon tetrafluoride. Xenon is actually noble gas, but remember, students, xenon is making a covalent molecule, right? Because of the existence of a greater number of electrons, it can make covalent bonds in this way. Look at this one. Number 1, xenon tetrafluoride, XeF4. Now we have to be very careful. In this way, xenon is connected to 4 fluorine atoms. Normally, fluorine is also connected to a particular atom through a single bond, right? Always remember that fluorine, generally, it is connected to an atom using a single bond. So therefore, fluorine is actually not making double bond, because if fluorine make double bonds, what will happen? It will have a positive sign. So therefore, it is not possible, because fluorine is the most electronegative atom in the periodic table. Okay. Now you can complete the octet of fluorine. 1, 2, 3. You can add the 3 lone pairs. And here also 3 lone pair students. 1, 2, 3. Okay. So you can check the valence electrons also. How? We know that this bond is actually representing 1 electron given by fluorine. So therefore 1, 2, 3, 4, 5, 6, 7. We know that fluorine actually belongs to the group number 17. So therefore in the valence shell there are 7 electrons. So therefore octet is satisfied. Valence electrons are also. So therefore nothing to worry about fluorine. Okay. Then we have to worry about xenon. Students, tell me, in the valence shell of xenon, how many electrons are there? Put your answers in the chat box. In the valence shell of xenon, how many electrons are there? Yeah, xenon belongs to group number 18. If it is belong to group number 18, definitely there should be 8 electrons in the valence shell. Neither. Then 1, 2, 3, 4. What about the remaining 4? Put 2 lone pairs. So, but xenon is exceeding the octet. Yeah, xenon can exceed the octet. Xenon actually belongs to helium, neon, argon, krypton, xenon. Xenon belongs to 1, 2, 3, 4, 5. Fifth period, right? 5 energy levels are there. So therefore, it can keep more electrons than 8. So therefore, xenon can exceed the octet. What we have to consider here is valence electrons. Can you see that in xenon tetrafluoride, any charges? No, students, no charges. So that's what I have done. While satisfying the octet, we have to consider the valence electrons also. When we consider the valence electrons in xenon, 1, 2, 3, 4, 5, 6, 7, 8 valence electrons are also okay. Therefore, xenon neutral. Fluorine, 1, 2, 3, 4, 5, 6, 7. When you consider total electrons, that is 8. Octet is also completed. Valence electrons also completed. Right? That's why I told you main rules actually we have to consider the octet and the valence electrons. Then accordingly we can put the charge. But remember, keep that in your mind. When we are assigning the charge separation should be minimized. Second example is PCl5. Look at this one, phosphorus pentachloride. This is actually following the rule number, this important fact number 5 that I told you. Phosphorus pentachloride. Phosphorus is surrounded by 5 chlorine atoms. We know that phosphorus main valence is 3. Therefore, it is the central atom. Chlorine is 1. So, therefore, it is surrounded by 5 chlorine atoms. Students, don't worry about the shape of the molecules. I will teach you the shape of molecules later. You just draw these things with me, okay? That's what I need from you. Then phosphorus is surrounded by 5 chlorine atoms. Normally, when chlorine is connected to an atom, that is also making one bond. Why? So this is actually the behavior of the halogen elements. Fluorine also same thing. Fluorine, chlorine, bromine, iodine. Halogens, group number 17. Only one electron needed to complete the octet. So therefore, mostly chlorine, fluorine-like elements are making a single bond in covalent compounds. So that's what that chlorine has done. Then, in order to satisfy the octet, 1, 2, 3 lone pairs. So therefore, octet is satisfied. And the valence electrons are also okay. No charge. There is no charge. So therefore, the PCl5 is look like this. So what about phosphorus? Nothing to worry. Phosphorus, valence electrons are 1, 2, 3, 4, 5. Phosphorus belong to group number 15. Nitrogen, phosphorus. So therefore, phosphorus is satisfying the valence electrons. Therefore, no charge. What about the octet? Phosphorus belong to the third period. And phosphorus is exceeding the octet. Doesn't matter. Third period elements like sulfur, phosphorus, chlorine, they can exceed the octet. The reason? Existence of the d sub energy level. If they want, they can shift the electrons for the d sub energy level in order to make extra chemical bonds. So here phosphorus can make 5 bonds. Students, remember, in most of the term test papers, they have asked that, not in the A-level, I think in the A-level examination also, they have asked one time, can NCl5, is NCl5 is existing? What do you think? Nitrogen pentachloride. Is it existing? That means nitrogen is making 5 chemical bonds with chlorine. No, it's not possible because nitrogen belongs to second period. If it is belong to second period, it can keep only 8 electrons. Now here we have 10 electrons. So these are statement type of questions. Be careful, right? Second one is also done. Now let's go for the third one. Number three. Number three is sulfur hexafluoride. Interesting. Sulfur hexafluoride. Sulfur, we know that the valence is 2. Main valence is 2. Fluorine is 1. Again, the same thing. Sulfur is connected to fluorine through single bonds in this way. Right? Then this is the structure. And we can put 3 lone pairs for fluorine in order to satisfy the octet and the valence shell electrons. In the valence shell, there are 7 electrons. The total number of electrons are 8. Okay. So what will happen if we miss one lone pair? Then students, your structure is wrong. Because fluorine is not satisfying the octet. So the marking examiner can cut off your marks easily. So therefore, please make sure to put these lone pairs perfectly, accurately. Understood? Now look at the sulfur. In the valence shell of sulfur, how many electrons are there? Exactly belong to sulfur. 1, 2, 3, 4, 5, 6. 5, 6. Are then okay? Because group number 16. So therefore, in the valence shell, there are 6 electrons. Then we can tell that the valence shell electrons are okay, therefore no charge. What about the octet? 2, 4, 6, 8, 10, 12. Octet is exceeding. Can exceed the octet? Yes, it can. Because again, sulfur belongs to third period. I told you that third period elements can shift the electrons to the d sub energy level and can make more than 4 bonds. So therefore, sulfur hexafluoride, the structure is look like this. Number 4. Number 4 is actually carbonyl chloride, COCl2. Carbonyl chloride. How look like this one? Carbon is the central atom, no doubt about it. Right? Valence is for oxygen 2, chlorine 1. And carbon is connected to oxygen through a double bond. Right? And chlorine can make single bonds. You can see that chlorine is satisfying the octet by having 3 lone pairs in this way. Carbon is also satisfying the octet but doesn't containing any lone pairs. 1, 2, 3, 4. And octet is okay. And I told you that oxygen, when it is neutral, definitely it is making a double bond. Or other way, we can tell that if it is a double bond, oxygen connected to another atom, definitely that oxygen is neutral. In order to satisfy the octet, we can put 2 lone pairs, 1, 2, 3, 4, 5, 6. Valence shell electrons are okay, no charge. Octet 2, 4, 6, 8. Everything is okay. Perfect. Carbonyl chloride, the structure is look like this. Number 5. Sulfur tetrafluoride. Earlier we discussed about sulfur hexafluoride. Now we have sulfur tetrafluoride. Okay. Now students, look at this one. Sulfur tetrafluoride. We consider that this is actually seesaw shape. Seesaw shape. We have to discuss about this shape of molecules later. Now you just remember this one only. Okay, this is seesaw shape. Okay. Now this is the way. We know that fluorine always connected to the element through a single bond. So therefore, in this way, it is connected to the sulfur atom. In order to satisfy the octet, we can put 3 lone pairs. Valence electrons are also okay. 1, 2, 3, 4, 5, 6, 7. Done. But students, you can see that sulfur is not, sulfur is satisfying the octet. It's okay. But sulfur is not completing the valence shell electrons. Sulfur contains 6 electrons in the valence shell. 1, 2, 3, 4. What are the remaining? Where are the remaining 2 electrons? We can put that remaining 2 electrons as a lone pair. If not, if you don't put this lone pair, what will happen to the sulfur? It means that in the valence shell there are 4 electrons. We consider that 2 electrons are removed. Then we have to put +2 charge. Is this correct? This is SF4, neutral molecule. We don't have any charges. Then we have to put the lone pair on the sulfur atom. Sir, but sulfur is exceeding the octet. I told you, sulfur belongs to third period. Okay, if it is third period element, can exceed the octet. Easy. Number 6. Number 6, actually, you can't decide the a skeleton, doesn't matter. So for the molecules that you can't decide the skeleton, I will give you, I will help you. So students, this is the skeleton for this molecule. Okay, this is the skeleton for the molecule. This is actually considered as methanoic acid. Right, methanoic acid. This is a carboxylic acid. You are going to learn this one under the unit number 7. Okay, or organic chemistry. 2 hydrogens, 2 oxygen atoms, and 1 carbon atom. How do you complete the structure? How do you complete the Lewis structure for this one? Right, we can see that hydrogen is always connected to atom through a single bond. I told you that one, right? Carbon, hydrogen, single bond. Oxygen, hydrogen, a single bond. Then students, you can see that, look at this carbon atom. In order to satisfy the octet, we need only one lone pair. And we can make this oxygen neutral by making a double bond. Then why don't we put here double? Let's put double bond. And put here 2 lone pairs to satisfy the octet. Then carbon is satisfying the octet. Oxygen is satisfying the octet. Valence shell electrons are okay. Carbon 4, oxygen 6. What about hydrogen? Okay, hydrogen is having maximum 2 electrons, right? Exactly 1 electron belong to hydrogen. Then this hydrogen is also okay. What about this oxygen? Student, oxygen here making 2 bonds, right? That is similar to double bond. From this side we have bond, and this side we have a bond. Then we can consider what? We can put here 2 lone pairs in this way. Then the octet is satisfied. 2, 4, 6, 8. What about the valence shell electrons? 1, 2, 3, 4, 5, 6. Then we can tell that valence shell electrons are also, right? No charge for the oxygen atom, and the valence shell electrons are also satisfied. Okay, assume that students, you can say that when oxygen is connected to 2 atoms from both sides through a single bond, it is similar to this double bond oxygen. Neither, because we know that when oxygen is connected to a double bond, we can put 2 lone pair and we can neutralize oxygen. Then this is the structure. Very easy. Okay, very easy. Yeah, octet can be exceeded, Hazika, but we can't exceed the valence shell electrons can't be exceeded. If it is exceeding, we have to put the charges, right? And octet can be exceeded only few elements like sulfur, phosphorus, chlorine. Keep that in your mind. Next one. Shall we go for the 7th one? 7th one is silicon dioxide. 7th one is silicon dioxide. Number 7, silicon dioxide. Students, when I look at the silicon dioxide molecule, to my mind, actually, carbon dioxide molecule is coming. Why? We know that under the group number 14, we have carbon, silicon, germanium, tin lead. So these are same group elements, carbon, silicon. So therefore, what is the valence shell electrons of silicon? 4. Then we can just connect oxygen atoms through double bond in this way. Done. We are done. May this is look like carbon dioxide, neither. This is look like exactly carbon dioxide, right? Carbon, silicon, both are same group elements. Therefore, we can assume that silicon dioxide also same way. Look at the valence shell electrons, 1, 2, 3, 4. Yeah, right. Valence shell electrons are 4 because silicon, carbon, both the elements belong to group number 14. What about oxygen? 2, 4, 6, 8, double bond. We don't have to consider anything here, any charges. So therefore, this is silicon dioxide, right? So you have to see these things. When you look at the silicon dioxide, you have to look at silicon dioxide like the way that you are looking at carbon dioxide. Right. Next one. Number 8. Okay, number 8 is a little bit difficult because you can't decide the skeleton. Therefore, I will help you. Number 8. Because students, don't worry, in the examination, they won't ask you what is the skeleton, right? We discussed past papers, A-level past papers in the online class. So I told you they are giving the skeleton. If it is a difficult molecule, they are giving the skeleton. You have to what? put the electrons and satisfy the octet, put the charges correctly. That's what they expect. So here also, I will give you the skeleton in this way. Okay, this is interesting, right? So from where you have to start this one? From where you have to start? You have to start from carbon. Why? Carbon hydrogen bond is there. And students, we can't make any double bond or triple bonds here because hydrogen can make only one bond. And here also we can see carbon hydrogen bond. And we can't what? Change that bond. We can't make, we can't put any other bonds. So therefore these bonds are permanent. Carbon has to satisfy the octet. Then are we going to put lone pair? Huh? Can we put lone pair? No, 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 no. Remember, if we put lone pair, what will happen? Carbon will have a negative charge because in the valence shell there are 4 electrons, 1, 2, 3, 4, 5. So therefore there will be unnecessary charge. Rather than putting a lone pair, how about if I consider carbon nitrogen double bond? Then carbon is satisfying the octet, right? And the valence shell electrons are also okay. 1, 2, 3, 4. So then what about nitrogen? Okay, don't worry. Remember, nitrogen, hydrogen cannot make more than one bond because hydrogen is there. Hydrogen is always making a one. So therefore, we have to forget about bonding here, hereafter. Nitrogen, hydrogen bond is permanent. Then how we can satisfy the octet of nitrogen? How we can reduce the charge of nitrogen? You can just put a lone pair. You count the valence shell electrons. 1, 2, 3, 4, 5. Nitrogen belongs to group number 15. So therefore, we can consider that nitrogen is actually valence shell electrons out. What about the octet rule? 2, 4, 6, 8. Octet rule is satisfied. Therefore, this is the acceptable Lewis structure for the CH3N molecule. Okay. Remember, students, you should be able to take decisions wisely when we are drawing the Lewis structure. Very simple thing. Sometimes at the beginning, you can't get the answer correctly directly. Doesn't matter. You try. Okay. Number 9. Number 9. CF2Cl2. Students, this is same as carbon tetrafluoride or carbon tetrafluoride. Carbon is the central atom connected to two fluorine atoms and 2 chlorine atoms, right? And I told you that fluorine, chlorine, both are halogens, making a single bond generally. So therefore, we can put 3 lone pairs to satisfy the octet. And while satisfying the octet, you can see that its valence shell electrons are also 7. 2, 4, 6, 7, 2, 4, 6, 7, 2, 4, 6, 7, 2, 4, 6, 7, and all the electrons are 8 around that particular. Carbon is also satisfying the octet. CF2Cl2. Okay. Carbon difluoride, dichloride. See how easy these things are. These things are not a big deal. Huh? Number 10. Number 10 is F2O. Again, when you look at this molecule, another molecule actually should come into your mind. Into your mind. Who is it? F2O. There is a molecule like F2O. Who is it? Yes, H2O. Right. So therefore, O, oxygen is the central atom because of the valency 2. Fluorine, we know that fluorine is always making a single bond. Then in order to satisfy the octet, put 3 lone pairs. Then I told you that when oxygen is connected through a double bond, charge is neutral. Double bond is actually, you can see separately, single bond here from the left hand side and the other one is right hand side. In order to satisfy the octet, you can just put here 2 lone pairs. Check the valence electrons 1, 2, 3, 4, 5, 6. And the octet is also satisfied 2, 4, 6, 8. Everything is perfect. Right? This is same as water molecule. Me? Can you remember the water molecule? This is same as water molecule. The only difference is chlorine replaces hydrogen. Number 10. No, we can't make double bonds in fluorine. Huh? If we put double bonds in fluorine, fluorine will have a positive charge. Okay, fluorine will have a positive charge. Next one. Number 11. Number 11 is CH3OH. This is students methanol. This is an alcohol. We can consider that CH3OH in this way. Carbon is connected to 3 hydrogens in this way, oxygen and hydrogen. Students, you have to understand that if carbon is connected to hydrogen in this way, these 3 bonds are permanent. We can't change. We can't change this one into a double bond. We can't change this one into a triple bond. We can't do anything because hydrogen can make only one bond. Then, what about this oxygen? I told you that oxygen is connected to 2 atoms from both sides. Then put 2 lone pairs, the atom becomes neutral. How? Octet is satisfied, name 1, 2, 3, 4, 5, 6, 7, 8. Then students, the valence shell electrons of oxygen 1, 2, 3, 4, 5, 6, that is also okay. And the other side we have hydrogen. Then this is the acceptable Lewis structure. So can't we put double bond here and here? Students, try to understand. Carbon, if it is making a carbon oxygen double bond, look at the valence shell electrons. 2, 4, 6, 8, 10. Can carbon exceed the octet? No, not possible. And hydrogen is making a double bond. Wrong, it's not possible. So therefore, this is the methanol Lewis structure. This is the Lewis structure for methanol, CH3OH, alcohol. Number 12. Number 12 is F3NO. F3NO. I will give you the skeleton for this one, students. I'll give you the skeleton for this one. This is look like this. N F F O F in this way, right? So nitrogen is connected to 2 fluorine atoms. So that is always single bond. Then we can put 3 lone pairs to satisfy the octet and the valence electrons because fluorine belong to group number 17, right? 2, 4, 6, 7 and 7 valence electrons are okay. And what about the octet rule? Octet rule is also satisfied and the other fluorine atom also same thing. That means better you can't make actually any differences between these bonds. And can you see that a centralized oxygen atom? That means 2 bonds are there. 1 bond from the left hand side, the other one is from right hand side. Then what we supposed to do? We have to put 2 lone pairs, right? This is kind of a double bond. And we know that again, fluorine is making double bonds or triple bonds, always single bond. Put 3 lone pairs and satisfy the octet. How about the valence shell electrons? 1, 2, 3, 4, 5, 6, 7. That is also okay. Oxygen 1, 2, 3, 4, 5, 6. Okay. And the octet is it octet is satisfied? 2, 4, 6, 8. All the electrons are 8. So what about nitrogen? Yeah, wait. 2, 4, 6. Octet is not satisfied. In the valence shell, there are 1, 2, 3 electrons. Then what we supposed to do? We have to put a lone pair. We have to put a lone. When we put a lone pair, what will happen? 1, 2, 3, 4, 5. Valence shell electrons are okay. Count the total electrons. 2, 4, 6, 8. Octet is satisfied. Okay. So let's remember there is a difference between counting valence electrons and the octet electrons. Okay. When we are calculating the valence electrons in a particular bond, we are considering only 1 electron. When we are counting the octet, you have to consider all the 2 electrons in the bond. Okay. So therefore, don't confuse with that one. I'm counting 2 types. 2 types of countings are there. Valence electron counting and the octet counting. Octet counting is actually including all the electrons, 2, 4, 6, 8. Valence electrons counting means one bond is representing one electron. So therefore 1, 2, 3, 4, 5. Okay. So then 12th one should be like this. Now let's go for the 13th one. 13th molecule. So the 13th molecule is ASH3. Students, can anyone tell me, when you look at ASH3, which molecule that come into your mind? Anyone? When you, yes, correct. Vidusana, correct. Ammonia, NH3. Why? Nitrogen, phosphorus, arsenic, antimony, bismuth, group number 15 elements. NH3, PH3, ASH3, SBH3, BiH3. Right? So therefore, this is kind of ammonia molecule. Then arsenic connected to 3 hydrogen atoms in this way. And you know that hydrogen never makes double bonds or triple bonds. Therefore, in order to satisfy the octet of arsenic, put a lone pair. What about the valence electrons? 1, 2, 3, 4, 5. We know that arsenic belongs to group number 15. Valence electrons are okay, therefore no charges. The Lewis structure should be like this. Octet 2, 4, 6, 8 completed. Easy, very, very easy. Okay. Yeah, it is satisfied even though it can exceed. Yes, it can exceed the electrons, but it is satisfied. Okay, there are some molecules also. Number 14. Number 14 is actually BRF5. Number 14, BRF5. Bromine pentafluoride. Students, can you tell me what is the central atom here? Bromine or fluorine? What do you think? What is the central atom? Who is the central atom here? Definitely bromine. Yes, definitely bromine. Now the valence is actually 1 and 1 because both are same. So then we have to go for that electronegativity. So therefore the most electropositive atom is the central atom and the negative atoms are the surrounding atoms. So therefore bromine is surrounded by 5 fluorine atoms in this way. 1, 2, 3, 4, 5. And you know that fluorine can make generally a single bond. It never makes double bonds or triple bonds. In order to satisfy the octet of fluorine, you can just put 3 lone pairs for each fluorine atom. Then you can see that octet is satisfied and the valence shell electrons are also okay. Now go for the bromine atom. Students, in the bromine atom, octet is already satisfied. Bromine is exceeding the octet. Bromine can exceed the octet. Doesn't matter. Okay. So here you can see that one. Valence shell electrons. In the valence shell of bromine, how many electrons should be there? 7, right? Group number 17. Count the valence electrons. 1, 2, 3, 4, 5. How many electrons we need? We need 2 more electrons. Then put a lone pair for the bromine atom. Easy. Can you understand? Right? 1, 2, 3, 4, 5. Forget about the octet. Bromine is already satisfying the octet. It is exceeding the octet. Even without this valence electrons, it is satisfying the octet. So therefore, 1, 2, 3, 4, 5, 6, 7. Bromine is 7. Valence shell electrons are okay. Right? Right. So that is the 14th molecule. Number 15 is hydrogen peroxide. Remember students, number 15 is hydrogen peroxide. H2O2. Hydrogen peroxide, H2O2. I will give you the skeleton for this one. Hydrogen peroxide is look like this. I'll give you with the correct shape. Okay, you are going to learn this one in inorganic chemistry. And this is the structure for the hydrogen peroxide. H2O2. Huh? So then how do you complete the Lewis structure for this one? Hydrogen is actually always making a single bond with the other atoms. Therefore, students, you can't make any differences between these two bonds. And students, I told you that when oxygen is connected to two atoms from the both side, oxygen from both side, so the central oxygen atom is neutral. Understood? So therefore, here we can see that we can apply two lone pairs, right? 1, 2, 3, 4, 5, 6. Valence shell electrons are 6. What about the octet? 2, 4, 6, 8. Octet is also satisfied. And the other oxygen atom also same thing. 1, 2, 3, 4, 5, 6. So therefore the valence shell electrons are okay. Octet is satisfied. Hydrogen peroxide, H2O2. Lewis structure should be like this. Number 16. Students, number 16 is actually C2Cl2. I will give you the skeleton for this one also. Number 16, C2Cl2. Okay. Carbon, carbon, chlorine, chlorine. Okay, this is very interesting. Huh? Look at this one, very interesting. Normally, I told you that chlorine is connected to carbon atoms or any other atoms through a single. So therefore, in order to satisfy the octet, let's keep 3 lone pairs and chlorine atom in this way. Then what about the valence shell electrons? 1, 2, 3, 4, 5, 6, 7. Okay. Octet is also okay. 2, 4, 6, 8. Then this bond is permanent. We can't change this one because chlorine is making a single bond. Then if you are making any changes, you have to put the lone pairs or any double bonds between this carbon. In order to satisfy the octet of carbon, shall I put here two lone pairs? What do you think? Is that correct? Is that correct? If I put here two lone pairs, 1, 2, 3, 4, 5, 6, then minus 2 charge. Oh my God, not possible. Not possible. Don't put lone pairs. Then what about if I put a double bond and a lone pair? Then the octet is satisfied. 2, 4, 6, 8. But count the electrons. 1, 2, 3, 4, 5. Valence electrons are 5. Again, we have a negative charge. So therefore, we can't do that one also. So what about if we try a triple bond? Yes. Yes. Better we try a triple bond. Students, when you try a triple bond, 1, 2, 3, 4. Valence electrons are okay, right? What about the octet? 2, 4, 6, 8. Satisfied, right? Go for the other carbon atom, right hand side one. 1, 2, 3, 4. Valence shell electrons are okay. What about the octet? 2, 4, 6, 8. Octet also satisfied. Or fine structure, right? With a triple bond. Carbon, carbon, triple bond. Remember, in organic chemistry, actually, students, we are learning a molecule like ethine. Actually, when I'm looking at this molecule, actually, the molecule that I came to my mind is ethine, C2H2. So here actually hydrogen doesn't containing any lone pairs, but since we have chlorine connected through a single bond and having 3 lone pairs. Okay, so therefore, I'm giving the Lewis structure for the ethine also in this way, right? So this is considered as alkyne. Single bonds are carbon-carbon, single bonds are alkane, carbon-carbon double bonds are alkene, carbon-carbon triple bonds are alkyne. I don't know whether you learned these things in O level. under the polymers. I think you had in O level grade 11, you had polymers and everything, right? So sometimes you may have learned that one, but doesn't matter. Anyhow, you have to learn these things. Number 17. So number 17 to number 25, I have given you again the structures with charges. Let's see. Number 17 to number 25, there are some structures with charges. Let's see how to deal with the charges. Cl F4 plus. Okay. Students, remember, definitely chlorine should be a central atom, surrounded by 4 fluorine atoms in this way. And we know that in order to satisfy the octet, we can put 3 lone pairs. For each fluorine atom, we can put these kind of 3 lone pairs, right? In this way. Right? Don't put plus charge for the fluorine. Why? Fluorine is the most electronegative atom. So therefore, you can't put plus charge for the fluorine atom. Not possible. Let's keep the plus charge for the fluorine atom. So now you can see that 1, 2, 3, 4. There are 4 bonds. Fluorine is satisfying the octet. No issue with the octet. But look at the valence electrons. 1, 2, 3, 4. Students, remember, chlorine is containing 7 electrons in the valence shell, right? So in order to complete that valence electrons, we can put here lone pair. Then 1, 2, 3, 4, 5, 6. Can I put here single electron? No, we can't put single electrons here. Since we have a positive charge, you can assign positive charge here. Sir, couldn't understand. How did you directly apply that positive charge? So it's very easy, Nimi. Look at this one. Listen to this one carefully. What did I do here? Fluorine connected to the chlorine atom through single bonds. Right? That is okay. Okay. And then we know that in order to complete the valence shell electrons, 1, 2, 3, 4, we can put 2 lone pair. Then how much? 5, 6. But there should be 7 electrons. We can't put lone pair. We can't put a single electron, unpaired electron. Because there are only 3 molecules we are learning in our syllabus with unpaired electron, NO, NO2, and chlorine dioxide. Right? NO, NO2, and chlorine dioxide. These are the 3 molecules, only molecules with just 1 electron. So therefore, forget about this one. Since there is a positive charge, now we can add here positive charge. Why? Positive charge representing that 1 electron is removed. Chlorine is containing 7 electrons. 1, 2, 3, 4, 5, 6. 1 electron is removed. Therefore, positive charge belongs to chlorine. Can you understand? So this is the Lewis structure for Cl F4 plus chlorine tetrafluoride ion. Okay. Students, at the same time, I have given you, after the 17th structure, I have given you that ClF4 minus. ClF4 minus. Listen to this one very carefully. Yeah? ClF4 minus. Chlorine tetrafluoride, and there is a negative charge. So same thing, chlorine is connected to 4 fluorine atoms, right? And we can put 3 lone pairs for fluorine atom in this way, right? This way. Okay. Now fluorine is actually satisfying the octet. Valence shell electrons are also okay. Then students, we don't have to assign this negative charge for the fluorine. So, but the most electronegative atom is fluorine, sir. Then we have to assign this negative charge for fluorine, right? Students, remember there are 4 fluorine atoms. If you have 4 charges, then we can assign. right? Even though we have 4 charges, we can't assign that one, okay? Remember, you have to adapt for the situation, right? So here fluorine is satisfying the octet. Valence shell electrons are also okay. So therefore fluorine doesn't need that electron, right? It doesn't need that electron. So therefore fluorine is letting chlorine to take that electron, right? That negative charge. Look at this one. Negative charge is representing that one electron is gained. Can you remember here we took that 6 electrons plus. Therefore chlorine had negative charge, right? Octet is okay already 2, 4, 6, 8. Now we have to consider the valence shell electrons of chlorine. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. Because of the 8th electron, chlorine will have the negative charge. Because in the valence shell of chlorine, there will only be 7 electrons. In the valence shell of chlorine, there are only 7 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now we have extra 1 electron. Because of that extra electron, we have to put the negative charge for the chlorine. Understood? This is the way that directly we apply the charges. Right? This is the way that directly we apply the charges. Yeah. Yeah, kind of exception now. So that is kind of exception. We can consider in that way. Fluorine is the most electronegative atom. So then we are assuming that fluorine will have a negative charge. But remember, so there are some standards. Standard means in the sense, if fluorine is there, if fluorine is somewhere, always, that means 99.9%, fluorine is a single one, no charges. So that standard is applied here also. So therefore, chlorine is taking that negative charge. Understood? That's what happened here. ClFO minus. Yeah, Fashan, this is can be considered as unstable structure, but yes, we can consider in that way because fluorine is the negative one. Chlorine has gained electron and forming a negative charge means somewhat unstable. Yes, we can consider in that way. Yes, good, very good. Huh? Number 19. Number 19, they have given NCO minus. NCO minus means students actually OCN minus, right? NCO minus, OCN minus, CNO minus, anything, right? So what is the central atom? Carbon, surrounded by nitrogen and oxygen. Students, now here we have to be very careful. Look at this one. Look. Carbon, nitrogen, oxygen is there. So where to put this negative charge and how do we satisfy the octet? Now, for example, if I consider carbon nitrogen double bond and carbon oxygen double bond, then carbon is satisfying the octet, right? And the valence shell electrons are also okay. 1, 2, 3, 4, the octet is also okay. If I put 2 lone pairs on oxygen, then that is neutral. If I put 2 lone pairs on nitrogen, octet is okay. 1, 2, 3, 4, 5, 6, negative charge is on nitrogen. Someone can consider this is the structure for OCN minus, right? Look at the next structure. I'm going to put carbon oxygen triple bond here. Then oxygen is positively charged. Carbon nitrogen, a single bond, 2 minus charge. Because 1, 2, 3, 4, 5, 6, 7. There are 7 electrons in the valence shell of nitrogen. But how many electrons are there exactly? In the nitrogen's valence shell? 5. But here we have 7. That means extra 2 electrons are there, 2 minus. But the overall charge is minus. Minus 2 plus 1 is minus. Right? So therefore, someone can consider this is the Lewis structure. And Another student actually consider that the Lewis structure of this molecule is this way. Carbon oxygen is making a single bond, therefore we know that oxygen having a negative charge. And carbon nitrogen triple bond, in order to satisfy the octet, we can put a lone pair 1, 2, 3, 4, 5. So therefore octet is satisfied. Students, tell me which structure is correct among these three. First one, second one, third one. Which one is the most acceptable Lewis structure for this one? Put your answers in the chat box. First one, second one, third one. Which one is the most acceptable one? Of course, it is third one. Yes. Yes, it is third one. Remember, second one directly we can reject. Why? I told you that when we are drawing the Lewis structures, we have to minimize the charge separation. Look at the charge separation video. Right? This side we have +1, the other side we have -2. Therefore, rejected. Second one, go home, right? First one, nitrogen is negatively charged. In the third one, oxygen is negatively charged. To which one you give the priority? Who is the most negative atom? Oxygen. Therefore, consider third one is the most stable structure. But is this wrong? First one, is that wrong? No, that is not wrong. That is correct. But they are expecting the most acceptable Lewis structure in the examination. Then this is the Lewis structure for OCN minus, right? Therefore, we can draw OCN minus Lewis structure is look like this. Right? No, Helindu. No, Helindu. So is a molecule usually unstable if it has charges when there are no cancelling of charges? No. Sometimes some molecules actually make charges in order to become stable. Now, for example, now look at this molecule, OCN minus. Now in OCN minus, definitely there should be a charge. Without having a charge, how that oxygen can exceed the octet? How this anion can exist? So therefore, there should be a charge. Sometimes we need a charge. Without charge, we can't draw the structure. Understood? So having a charge is not making the molecule unstable. Try to understand, Hindu, right? Having a charge is not making the molecule stable or unstable. Okay? So if it is necessary, we have to put the charge. Yeah, Fashan, if they ask the resonance structures, we can draw that one too. Yes, good. So why nitrogen asthma? So why oxygen nitrogen double bond with carbon is not acceptable? No, I didn't tell you that is not acceptable. It is acceptable, but I'm telling you that the most acceptable one, right? Now, nitrogen oxygen double bond. Nitrogen is having a negative charge, right? So therefore, nitrogen is having a negative charge. Nitrogen is having negative charge, and here oxygen is having negative charge. Which one is the most acceptable, right? I didn't tell you that this is not acceptable. This is also acceptable. A structure for OCN minus. But the most acceptable one is this, because oxygen is the most electronegative atom. The most electronegative atom is having a negative charge, is making that molecule stable. In the resonance structures, we are learning these things, okay? What is that, students? The most electronegative atom is having a negative charge, is making that molecule stable. And the opposite thing also. The most electronegative atom is having the positive charge in the molecule makes that molecule unstable. Understood? So therefore, I didn't say you that this is structure wrong, but this is the most acceptable one, right? Keep that in mind. And Hazika, and hydrogen peroxide, can't it be triple bond? So no need triple bond, right? In hydrogen peroxide, we know that oxygen atom is centralized and two bonds are there. So why we need to have triple bond? So we have to put triple bond. Actually, if you are putting a triple bond, we have to put triple bond between these two oxygens. Then look at this one. Octet is satisfied. But what about the valence electrons? 1, 2, 3, 4. So therefore, we have to put +2 charge. And here also we have to put +2 charge. Oh my God, very unstable. Hydrogen peroxide molecule is a neutral molecule. Understood? This is what happened when we put triple bond between oxygen atoms. Because we have to consider the valence electrons also. 1, 2, 3, 4. In the valence shell of oxygen, there should be 6 electrons. We can't put a line pair. I can't understand what does mean by line pair. Line pair means double bond. The same thing, right? If you put double bond, what will happen? So 1, 2, 3, we have to put a lone pair again here. 1, 2, 3, 4, 5, positive charge here, positive charge here. So therefore not possible. So therefore what we have to do is keep the single bond here and put two lone pairs. 1, 2, 3, 4, 5, 6. Valence electrons are okay. So therefore neutral. 1, 2, 3, 4, 5, 6. Okay. Octet is also okay. Right? Okay. Now let's move to the 20th one. HPO4 2 minus. Okay. I will help you to draw this one. HPO4 2 minus. HPO4 2 minus. Here we can say that in this way. How we can draw the structure for this one? 2 minus charge is there. Phosphorus is the centralized atom. Okay, students. So this is the skeleton. Students, this is the skeleton for the HPO4 2 minus. So you can decide that before we draw the structure, you can decide that since oxygens are existing, we can tell that 2 minus charges belong to two oxygen atoms, right? And we know that here we can see that students hydrogen is connected. So therefore we can't change the structure in this way. We can just put here two lone pairs to satisfy the octet and complete the valence shell electrons. Look at the hydrogen peroxide molecule. In the hydrogen peroxide molecule also we did the same thing, right? So there are two bonds from the both side. Then put two lone pairs and satisfy the octet. Valence shell electrons are also okay. 1, 2, 3, 4, 5, 6. Then we have two minus charges, two negative charges. So what I'm going to do here, if there are two negative charges, okay, when oxygen is directly connected to an atom through a single bond, put three lone pairs and negative charge. Why? Count the octet 1, 2, 4, 6, 8. Okay, octet is completed. Look at the valence shell electrons 1, 2, 3, 4, 5, 6, 7 in the bond. Then we know that on the oxygen there should be 6 electrons, but here we have 7. What about this one? I'm going to make another negative charge for the oxygen atom, right? Then okay. So what about this oxygen? Now we can't make another negative because only two negative charges are there. So therefore, let me make a double bond oxygen here to neutralize. 1, 2, 3, 4, 5, 6 valence shell electrons are okay. Octet 2, 4, 6, 8 octet is also okay. So what about phosphorus? You didn't consider anything related to phosphorus. Students, phosphorus is automatically satisfying everything. Octet exceeding doesn't matter. Then valence shell electrons, phosphorus 1, 2, 3, 4, 5. In the valence shell, phosphorus is containing 5 electrons because phosphorus belong to group number 50. So the 20th structure is look like this. Okay. You have to practice these molecules again now, right? So discussing this 50 molecules doesn't mean that hereafter Lewis structures will be easy for I can draw anything. It's not like that. You have to practice these things continuously. Understood? So this is kind of a help that I'm going to give you in order to give a start. Okay. In the theory class, we discuss about 20 molecules again. So that much only we can discuss in the theory class because we can't take a lot of time. So that's why I have taken a separate time and I'm explaining you these things. Understood? These are some common structures that we are meeting in our syllabus, right? Practice these things again and again. That's what important. Number 21. NH2 minus amide. Nitrogen is connected to two hydrogen atoms in this way. So students, when nitrogen is connected to two hydrogen atoms in this way, we can say that we can't make any changes in these bonds. Ne? What to do? Hydrogen is connected to nitrogen. We can't make any changes. We can't make any double bonds, triple bonds because it is hydrogen. Then in order to satisfy the octet, what we have to do? We have to put two lone pairs. We don't have any option, right? Then count the octet 2, 4, 6, 8. Okay, octet is okay. What about the valence shell electrons? 1, 2, 3, 4, 5, 6. There should be 5 electrons. We have 6 electrons, 1 electron extra. Therefore, the negative charge on nitrogen. Correct? NH2 minus. That negative charge belongs to nitrogen. (22) Students, 22 is also some kind of an exception. IF4 minus. We are expecting that negative charge belongs to fluorine, but it's not the case. Look at this one, okay? Carefully. Iodine connected to 4 fluorine atoms. I told you that fluorine is always making a single bond. Neither. Then complete the octet. While checking the valence electrons, we can see that fluorine nicely completing the octet and the valence electrons are okay. What about the iodine? Iodine is satisfying the octet by default in this. Then nothing to worry about octet. Then go for the valence shell electrons of iodine. Belongs to group number 7. There should be 7 electrons. 1, 2, 3, 4. We need 3 more. Let me put another lone pair. Then in order to satisfy the octet, in order to satisfy the valence electrons, we need single electron. But students, there is a negative charge. Then we can take another electron and put the negative charge. Oh, wait. What did I do here? In the valence shell of iodine, how many electrons are there? 7. Here, how many are there? 1, 2, 3, 4. So, in order to fill those 7 electrons, we can put a lone pair. 5, 6. 1, 2, 3, 4, 5, 6. 7, there is a negative charge, right? 1 electron is gained. And we can't put just 1 electron, single electron, put another electron, put the negative charge. 1, 2, 3, 4, 5, 6, 7, 8. 1 electron is in extra. Therefore, the negative charge belongs to iodine, not for the fluorine. Learn these things. 23rd one. (23) C2O4 2 minus. I will help you to draw the Lewis structure for this one, a skeleton in this way. This is C2O4 2 minus. Remember, students, this is considered as oxalate anion. Oxalate anion, right? How to draw the Lewis structure for this one? Students, very easy. Why? You can see that carbon is now already forming 3 bonds. In order to satisfy the octet, we have to put the, if you want to satisfy the octet, you can put a lone pair for carbon. But there is an issue. 1, 2, 3, 4, 5. Valence electrons are 5. Octet is satisfying. So therefore, carbon is having negative charge. When there is an oxygen atom, how do you put the negative charge for carbon? Remember, oxygen will protest, okay? So therefore, we can't put the negative charge for the carbon. We have to put the negative charge for the oxygen. So then what is the method to satisfy the octet of carbon? Students, you can just make one double bond with, between oxygen and carbon. Then here we can put 2 lone pairs. 1, 2, 3, 4, 5, 6, octet is okay. Valential electrons okay. Carbon octet is okay. Valential electrons okay. But we have a remaining 1 oxygen connected to the carbon through a single bond. Then if it is a single bond, we know that there is a negative charge on the oxygen. 1, 2, 3, 4, 5, 6, 7. 1 electron is in excess, therefore negative charge. What about octet? 2, 4, 6, 8. Octet is okay. I think, students, you can do the same thing for the other side. Double bond, 2 lone pairs, 3 lone pairs, negative charge. 2 negative charges belong to oxygen. Fair, ne? It's fair. Completely fair. If you put 2 lone pairs on carbon and put the negative charges for the 2 carbon atoms, it's not fair. Because carbon is not the electronegative atom here. Okay? That is the way. In today's explanation, you can learn a lot of things. Okay? Be wise to understand everything. Be wise to take the things that I'm teaching here. Okay? (24) 24 is PO4 3 minus phosphate. Yeah, Asma, that is correct. That's okay. That is completely fine. Yeah, Teshala, you also did the same thing, right? Yeah, that is completely okay. That means students, some of the students actually drawn the structure in this way also. That means, look at this one. What about if we draw the structure in this way? Double bond here, single bond here. Right? So this is actually resonance structure. Resonance structure means same molecular formula but different two structures. So this is also okay. Understood? Otherwise, we can consider here we have a double bond, single bond, and here we have double bond, single bond. That is also okay. Ne? That means here we have negative. Here we have negative charge, double bond, and here also double bond. Yeah, totally fine. Right? And if you want, you can make a double bond here and double bond here. That is also, yes, up and down, left and right, you can exchange that. Doesn't matter. Number 24. Number 24 is phosphate, PO4 3 minus. PO4 3 minus. Phosphorus is connected to 4 oxygen atoms in this way. Right? So, students, you can see that how many charges are there? 3 minus. That means 3 minus charges means we have to put these 3 minus charges to 3 oxygen atoms. Right? Look at this one. 1. We can put 3 lone pairs in order to satisfy the octet. So 1, 2, 3, 4, 5, 6, 7. Then one electron is in excess, negative charge. Octet is satisfied. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Negative. And this one also negative. And the other one, you can keep that one as a double bond oxygen. Then it is neutral. I told you, if it is a single bond oxygen, that is negatively charged. If it is a double bond, neutral. If it is a triple bond, positively charged. 1, 2, 3, 4, 5, 6. Valence electrons okay. Octet is also. So what about the phosphorus? Phosphorus is also okay. Octet is anyhow satisfied. What about the valence electrons? 1, 2, 3, 4, 5. So therefore, charge 0. Phosphate, PO4 3 minus, is look like this. Number 25, interesting. H3O plus, considered as hydronium. H3O plus, considered as hydronium. Oxygen is the central atom. 3 hydrogens. Students, tell me, now hydrogen is connected to the oxygen atom through a single bond. Now see this one. This is exceptional. This molecule is exceptional. Now we have a positive charge. Oxygen is the negative atom here. Hydrogen's electronegativity is 2.1, oxygen is 3.5. Then we are expecting that this positive charge belongs to hydrogen. But it's not what happened, right? So hydrogen is always making a single bond. I told you that one. Hydrogen is always making a single bond. No change with that one. Then we can't do any changes between the oxygen-hydrogen bond here. So therefore, we have to keep the hydrogen at its. So let's first of all try to satisfy the octet of oxygen. Let me put a lone pair. Because we can't make double bonds. Put a lone pair. Now octet is satisfied. Count the valence electrons. 1, 2, 3, 4, 5. Normally there should be how many electrons? 6 electrons. Now here we have only 5. Then students, you can understand 1 electron is removed by oxygen. Then oxygen is positively charged. What to do? With hydrogen, oxygen can't do anything. Right? Oxygen can't remove the hydrogen. Right? Oxygen can't make double bonds with hydrogen. Oxygen can't make triple bonds with hydrogen. Can't do anything with hydrogen. Just single bond. Hydrogen is neutral. What to do? Then oxygen has to take the positive charge. Okay, even though that is electronegative. 26, NOF. NOF is actually again a neutral molecule. But let's see whether we have overall charge becoming 0. Start separation. Nitrogen is the central atom, right? Surrounded by oxygen, fluorine. So directly I'm going to make oxygen and fluorine neutral. Okay, fluorine neutral when we put 3 lone pairs. 1, 2, 3, 4, 5, 6, 7. Valence electrons are okay. Octet is also satisfied. What about oxygen? Make a double bond, put lone pairs. 1, 2, 3, 4, 5, 6. Valence electrons are okay. Octet 2, 4, 6, 8, okay. So what about nitrogen? Nitrogen is not satisfying the octet. Put a lone pair. 1, 2, 3, 4, 5. Valence electrons are okay. Octet is satisfied. This is NOF. Perfect molecule. Okay. That's good. Octet valence, octet valence, octet valence. That's what always in our mind working when we are drawing the Lewis structures. Next one. 27 we already discussed in the theory class also. In the tutorial I have given you the examples, so it doesn't matter. I will give you the skeleton and let's complete the structure for this one. 27 is N2O3 and 28 also interesting. N2O5. Shall I give you the skeleton for N2O5 also? Those who can try this one, now you can try. This is the skeleton, no? N2O5. So the N2O3s look like this. In this way. Okay. Students, what I'm going to do here is in N2O3, Since we don't have any charges, let me try to put double bond between this nitrogen oxygen. Then oxygen is neutralized. Okay. So the next thing is I'm trying to complete the octet of this nitrogen having a lone pair. Then okay. Ne? So 1, 2, 3, 4, 5 valence shell electrons are okay, and the atom is also neutral. And I'm trying to make this atom also neutral. And first of all, I'm going to satisfy the octet. 1, 2, 3, 4, 5. Okay. But what about the octet? 2, 4, 6, 8. That is also okay. But remember, oxygen is connected through a single bond. Then students, oxygen are having negative charges. Wrong. Wrong. This is completely wrong. So therefore, this can't happen. So therefore, what I'm going to do here is, what about if I make nitrogen oxygen double bond here? Then this oxygen become neutral. 1, 2, 3, 4, 5, 6. Okay. Valence electrons are okay. Octet is okay. Oxygen, this one is negative. Octet is okay. Remember, nitrogen, octet is satisfied. But the valence electrons 1, 2, 3, 4. Valence electrons are 4. So therefore, there should be 5 electrons. Nitrogen is positively charged. Right, students? We don't draw the structure without positive charge and negative charge. We can't do that one. When we are drawing the structure for the N2O3, we can't do. We can't remove this plus and minus. See, this is what we can do the maximum in this, right? N2O3 look like this. N2O5, when I look at this molecule, actually, what I feel, first of all, is actually to put 2 lone pairs on this oxygen atom. Then the central atom is neutralized. Then the issue is starting from here, these atoms, right? What we have to do? We can make this oxygen atom neutral by adding 2 lone pairs. Okay. Can we make neutral this oxygen atom also? Can we do that one? Then nitrogen is exceeding the octet. 2, 4, 6, 8, 10. Can't do it. Therefore, this is the maximum number of bonds that nitrogen can form. So we don't have any option. We have to put 3 lone pairs for these oxygen atoms. 1, 2, 3, 4, 5, 6, 7 negative charge. 1, 2, 3, 4. Valence electrons is, valence shell is containing 5 electrons, but here 4 positive, positive, and this is negative. What to do? Right? We can't do anything than this. This is the maximum that we can do. Even though N2O5 is a neutral structure, the charge separation is a little bit greater. But we can see that overall charge is becoming neutral. Understood? Plus minus cancel of plus minus cancel. N2O5. 29. Sulfuric. I'll draw the skeleton, students. Third one is phosphoric. How to draw the Lewis structure for this one? Oxygen, hydrogen, single bond. And we can put two lone pairs in this way. And in order to neutralize oxygen, we can put double bond and two lone pairs here. Right? Then everything is neutral. But look at the sulfur atom. 1, 2, 3, 4, 5, 6. Valence shell electrons are okay. Octet is exceeding, doesn't matter because sulfur belongs to third period. So this is sulfuric. Lewis structure for the sulfuric molecule. Look at that one. Lewis structure for the sulfuric. If you put double bond here, what will happen is actually oxygen will have a positive charge. So therefore we can't consider it. This is the most acceptable way. Phosphoric, put two lone pairs in this way. Right? Same thing that we discussed. And in order to neutralize, here we can put two lone pairs. Right? Phosphoric and sulfuric. Phosphoric acid and sulfuric acid.
நீங்க இனிமேல் பாத்துக்கொண்டு நான் உங்களுக்கு அடிக்கிற பாருங்க.
Please mute your microphones. Yeah, Nilukshan, okay, yeah, it's fine. It's fine, Nilukshan. You can have the link. Right. So the next one, students, the numbering is wrong actually, right? H3PO4, the next one should be again H2C2O4 is oxalic acid. So that is 31. No? 31 oxalic acid. H2C2O4. How do we draw the structure? Can you remember earlier we drew the Lewis structure for oxalate? Oxalate anion. For the same oxalate anion, we are going to connect two hydrogens. That's what we are going to do. For the same oxalate anion, we are going to connect two hydrogens. Look at this one. This is very interesting. So in oxalic, we know that the molecule is neutral. So therefore, what I'm going to do here is I'm going to give this lone pair for the hydrogen. And this lone pair for the hydrogen. Then it becomes oxalic. Easy. Right? Oxalic. This acid is known as oxalic acid. H2C2O4. Lewis structure. Next one. 32. MnO4 minus. Okay, very interesting. Here comes the D block. D block Lewis structures. Normally they won't ask these things, but we have to learn. D block Lewis structures, MnO4 minus. Can you remember, students? We learned that manganese oxidation state is +7 in permanganate. X minus 2 into 4, summation is equal to -1, X equal +8 minus 1 +7. So therefore, it means that manganese can have 7 oxidation state, means it can make 7 bonds. Look at this only. Look, manganese in this way. 1, 2, 3, 4, 5, 6, 7. Can you remember I told you how to calculate the oxidation state using the bonding method? Right? That means the most electropositive atom will have +1, -1, +1, -1, +1, -1. Right? +1, -1, +1, -1, +1, -1, +1, -1. So now when you get the summation, what is the answer? +7. That means the oxidation state. So that is the valency. The valence electron is also 7. Right? So therefore, MnO4 minus permanganate should be drawn like this. Permanganate. Okay. 33. 33 is manganate. MnO4 minus. This is permanganate. MnO4 2 minus is manganate. I taught you these things earlier. Manganate. Then here, Mn, 2 oxygen atoms, negatively charged 2 oxygen atoms are there, single bonds. And others are double bonds in this, right? Can you remember, students? Manganese, x minus 2 into 4 summation is minus 2. Then x equal +6. That means manganese can make 6 bonds here. And when you calculate the oxidation number using the bonding method, -1 + 1, -1 + 1, -1 + 1, -1 + 1, and here also +1 + 1. Overall, oxidation state is become +6. Right? So therefore, it's following the Lewis structure also. MnO4 2 minus, manganate. Here comes the next one, 34. 34 is chromate, CrO4 2 minus. By looking at the oxidation state, you can decide that one. Chromium, right? 4 oxygen atoms, 2 minus charges are there. Then students, you can tell that if it is 2 minus charges, that 2 minus charges belongs to oxygen. Then connect that one through single bond, minus minus here. Then chromium oxygen making double bond. Right? Chromium's oxidation number is what? +6 here. You do the calculation. Then when you go through the bonds, -1 + 1, -1 + 1, -1 + 1, -1 + 1, chromium will be +6. See how the oxidation number is also connecting to these Lewis structures. Interesting. Next one, dichromate, Cr2O7 2 minus. Cr2O7 2 minus. I'll give you the skeleton for this one. Okay, don't worry. Oxygen connected to chromium atoms. Oxygen, oxygen in this way. Right? So the central one can be neutralized by adding lone pairs in this way. Valence electrons are okay, 1, 2, 3, 4, 5, 6. Okay, this okay. And there are 2 minus charges. Students, we can say that chromium's oxidation number is +6, right? Therefore, it can make 6 bonds. Okay? 1, 2, 3, 4, 5, 6. Then the remaining oxygen is negatively charged because it has a single bond. Others are neutral. Now you calculate the oxidation state. -1 + 1, -1 + 1, -1 + 1. So +6. Right? Therefore, there should be 6 bonds. Same thing for the other chromium atom also. Double bond, double bond. And here we can have single bond because oxygen should have a negative charge. There should be 2 oxygen atoms with -2 charge. 35. Dichromate should be like this. Lewis structure for the dichromate should be like this. Next one, 36. POCl3. Phosphorus is the central atom. Oxygen, chlorine. We know that chlorine is always actually making a single bond. And oxygen, we can make a double bond. So oxygen, chlorine, everything is satisfying the octet as well as valence shell electrons. Phosphorus exceeding the octet doesn't matter. Third period. What about the valence shell? 1, 2, 3, 4, 5. Okay, perfect. POCl3. 37. BrO3 minus. BrO3 minus. Bromine is connected to 3 oxygens. Students, we can see that only there will be a negative charge. Therefore, we can keep one oxygen atom with the negative charge here in this way. Then bromine atoms connected to the oxygen through double bonds. Other remaining 2 oxygens. Right? Then 1, 2, 3, 4, 5. In the valence shell of bromine, there should be 7 electrons. Only 5 are then put lone pair. It is exceeding the octet, doesn't matter. Right? Doesn't matter. So BrO3 minus should be like this. Next one, selenate. SCO42 minus. Can you remember selenate is group number 16, oxygen, sulfur. Actually, when I look at the selenate, I can remember sulfate. Right? Sulfate. Sulfate is also same thing. Okay. Anyhow, 2 minus charges are there. Then students, we can make 2 oxygen atoms with 2 negative charges by making single bonds. And the other oxygen atoms can be connected through double bonds. You can study here the contribution of the oxygen atoms for the Lewis structures, right? You can understand here how much contributed by oxygen for the Lewis structures, me permanganate, dichromate, chromate, POCl3. I think the most of the Lewis structures are containing oxygen, right? That's why I gave you a separate rule for the oxygen as well. Okay. So then students, these things are okay. Selenium, what about selenium? The valence shell electrons 1, 2, 3, 4, 5, 6. Okay, because selenium belongs to group number 16. In the valence shell, there are 6. Got it? Then next one, 39. XCO2F2. Xenon is the central atom. Fluorine is connected to xenon through single bond. Oxygen in this way, double bond. Let's try to make the molecule neutral. And fluorine, there should be 3 lone pairs to neutral the atom. So what about xenon valence shell electrons? 1, 2, 3, 4, 5, 6. Still, actually, we have remaining lone pair should be electron. Xenon is exceeding the octet, isn't it? Right? Count the valence shell electrons 1, 2, 3, 4, 5, 6, 7, 8. Xenon belongs to group number 18. Okay. Number 40. SO2 F2. Sulfur, central atom. Oxygen, fluorine. Students, fluorine is always making a single bond. With oxygen, what you are going to do? Make a double bond. To neutral, make it a double bond. What about the valence electrons of sulfur? 1, 2, 3, 4, 5, 6. Okay. 6 electrons. What about the octet? Octet is exceeding, doesn't matter, because sulfur belongs to 30. Then we have 41. PO2F2 minus. PO2F2 minus. Let's see. Phosphorus, oxygen, in this way. There is a negative charge, but remember, fluorine can't have charges, students. That is the thing. Fluorine is the negative one. We know that fluorine is the most electronegative one, but fluorine cannot make bonds. Fluorine cannot have the charges. Therefore, put the 3 lone pairs and neutralize the atom. And the valence electrons are okay, 2, 4, 6, 7. There is a negative charge, right? I think probably that should belongs to oxygen, right? Single bond are then negatively charged. 1, 2, 3, 4, 5, 6, 7. And the other oxygen should be neutral. 1, 2, 3, 4, 5, 6, 7, 8, octet. What about the phosphorus? 1, 2, 3, 4, 5 valence shell electrons are okay. Octet is also satisfied. So therefore, the negative charge belongs to oxygen here. Oxygen here. PO2, F2 minus. (42) is HNO3. HNO3 is look like this. Oxygen, there are 2 bonds. We can put 2 lone pairs. This is like a double bond. Here we can put lone pair students, because when you put lone pair 1, 2, 3, 4, 5, and here oxygen will be negatively charged, and this oxygen also negatively charged. So therefore, the molecule is charged. So it can't be. Therefore, what we have to do is we have to make a double bond between oxygen and nitrogen. Then make one oxygen neutral. The other one is negatively charged. What about nitrogen? Valence shell 1, 2, 3, 4. Then nitrogen is positively charged. HNO3, Lewis structure. Nitric acid is look like this. I think we discussed about phosphoric acid, sulfuric acid. This is nitric acid. Okay. So these are frequently used acids in our syllabus. N2O4. Students, in NO2 molecule also, we can make double bond between nitrogen and oxygen. And single bond between nitrogen and oxygen, therefore oxygen is negatively charged. Here also oxygen is negatively charged to a single bond. Here we can make that nitrogen oxygen double bond. Nitrogen is positively charged here, positively charged. So this is actually N2O4. Okay, this is considered as N2O4 molecule. Nitrogen is having extra electron, or it is positive. Nitrogen doesn't have extra electron. 42nd mark. So to tell me, where is the extra electron? 1, 2, 3, 4. That means 1 electron is in less. There should be 5 electrons, but here we have 1, 2, 3, 4. Can you understand, Azma? So we don't have any extra electron, right? 1, 2, 3, 4. So therefore, 1 electron is less, so therefore positive charge. Next one, Cl2O7. Cl2O7, I will give you the skeleton, don't worry. So this is neutral. Students, therefore, what I'm going to do is I'm making everything double bond. How about this? So what about chlorine atom? Octet is anyway exceeding, doesn't matter. Valence electrons 1, 2, 3, 4, 5, 6, 7. Okay. Cl2O7. Dichlorine heptoxide. Dichlorine heptoxide. Chlorine can exceed the octet. So therefore, na 44. Here we have oxo acids. These are the oxo acids that we discussed. Ne? Can I remember? We discussed some oxo acids. These are the Lewis structures of the oxo acids. Hypochlorous acid, chlorous acid, chloric acid, perchloric acid. So therefore, 45. HClO. Right? So therefore, structure is look like this. We can't make any difference between chlorine hydrogen, but we can make double bond between chlorine oxygen. In order to satisfy the octet, we have to put lone pair. But we can see that 1, 2, 3, 4, 5. In the valence shell of chlorine, there should be 7 electrons. 1, 2, 3, 4, 5, 6, 7. Then this is the hypochlorous acid. Then we have HClO2. HClO2 is look like this. This is the skeleton. HClO2. Chlorous acid. Students, remember, here we can see that oxygen and chlorine, oxygen is actually surrounded by hydrogen chlorine. Therefore, 2 lone pairs. In order to neutral this oxygen, let me put here double bond and 2 lone pairs. Then you can put here 2 lone pairs for chlorine. Why? 1, 2, 3, 4, 5, 6, 7 valence shell electrons are okay. Valence shell electrons are okay. HClO2. 47. HClO3. So here also chlorine is the central atom. Look at this, Anil. Oxygen, oxygen, oxygen. Hydrogen here. We can put 2 lone pairs in order to satisfy the octet and the valence electrons. Here we can make double bonds. Here also we can make double bonds. 1, 2, 3, 4, 5. Then we can put a lone pair for the chlorine. Everyone is satisfying the octet. Right? HClO3. So if chlorine is central atom, then can it make multiple bonds? Yes, Asma, that's correct. That's a good point. If chlorine is surrounding atom, it can't make double bonds, but really it's forming. When chlorine is the central atom, it has to make double bonds or triple bonds. Mainly it is forming double bonds. That's a good point, okay? That's a good point that you have to note down. When chlorine is the central atom, it can make double bonds. (49) HClO4. Here we can see that chlorine, 4 oxygen atoms are there. Then students, you have to consider all the oxygen atoms should be neutralized. No charges. Then here also 2 lone pairs. So what about chlorine? 1, 2, 3, 4, 5, 6, 7. Okay, valence shell electrons are okay. What about the octet? Octet is exceeding, doesn't matter. Chlorine belongs to third period. Then students, again they have given N2O5. I think we have discussed that one. So therefore I will go for the next one. That is the 50 molecule, right? This is 48. Then 49 is dimethyl ether. This is also very easy. I'll give you the skeleton in this way. CH3, O, CH3. Students, you can see that already carbon is satisfying the octet. Valence shell electrons are okay. Hydrogen is anyway making a single bond. So therefore, we can put 2 lone pairs on oxygen to satisfy the octet. 2, 4, 6, 8. Valence electrons 1, 2, 3, 4, 5, 6. Octet is satisfied. Valence electrons are okay. Understood? That is it. Then 50th one is acetic acid, CH3C double bond OH. 50th one is acetic acid, CH3C double bond OH. I'll give you the structure for this one in this way: CH3COOH. This carbon atom is satisfying the octet. In order to complete the octet of this oxygen, we can put 2 lone pairs, and the valence shell electrons are 1, 2, 3, 4, 5, 6. Okay. And we can make double bond. Then this is neutral. Carbon is satisfying the octet. Valence shell electrons are okay. Acetic acid. Last molecule, 51. Propane. CH3, CH2, CH3. Students, you don't have to do anything here. You have to just draw the chain. Can you see that in the last structure I gave you, all the carbon atoms are satisfying the hydrogens, nothing changes. In organic molecules, we don't expect the Lewis structures. We just write down the molecule in this way: CH3, CH2, CH3. Acetic acid, this is the way that we are writing. Okay, so therefore, in the second unit only, we are discussing the Lewis structures. But when we go for the inorganic, organic, we do not consider that much of Lewis structures. But we have to know these basic stuffs here in the second unit. Because in the organic chemistry, like more lessons, we have to discuss so many things, students. With that one, Lewis structure practice exercise is done. Okay, I think that I did my maximum to explain these things. So now it is in your hand. You have to practice these 50 molecules again and again and again and try to understand the concept. Okay, if you can find more structures, do them. If you can't do them, ask from me. I will help you. And if you have any doubts, you can ask from me. Okay, right. Students, now time is 11:30 and I have discussed all the Lewis structures exercise. Tomorrow in physical class, in Vellavatta class, Master Academy, we are starting redox reactions. In online class, we are discussing structure and bonding part. For the online class, redox reactions are starting in the following week. That means the next week, not this Thursday. So that is the plan for now. Understood? Right. If there is a chance, let's do the past paper discussion is there. Remaining part is there. Let's try to do that one in this Saturday. If I have time, I will do that one. I will inform you that one. Right? Okay, students. Then time is up. Let's wind up the session. How was the session today? Did you get something from this session? Lewis structures. Right. Right. Okay. Then let's meet on the next class. Until then, bye bye. Have fun. Good night for all of you. God bless you.